Good day, 20-1s. Welcome to Chapter 1, Sequences and Series. This is an interesting unit, one of my favorites because it's a whole bunch of algebra. What we're looking at with sequences series, it's very formula-based for different situations. And then with those formulas, we got a whole bunch of algebra working. So that's what we're looking at. Formulas and algebra for unique, specific situations. Please understand with this, what you are looking is sequences, which are lists of numbers, but they're specific lists of numbers. 2, 4, 6, 8 could be a sequence. 1, 5, 25, 125 is another possible sequence situation. Why? Well, we see that to go from number to number here, we're adding 2 each time. Here, we see that to go from number to number, we're multiplying by 5 each time. 2 different types of sequences we'll look at. A series is very much the same idea, but instead of just listing numbers like in a sequence, series are when we actually add the values in a series to come up with a sum. So very similar in terms of how it works, but significantly different in that sequence we're listing and series we're adding. So that's what we're looking at doing. Let's just take a look at what we're doing. So in your booklets, if you turn to page 2, we're going to start the lesson, or this chapter's lessons, with arithmetic sequences. And an arithmetic sequence is basically a sequence where we are adding to go from number to number. So like I just had on the other page, 2, 4, 6, 8 is an arithmetic sequence, a list of numbers where we are adding a consistent value to go from number to number in the list. That's what we're going to be looking at doing. With sequences and series, though, there's a terminology for the formulas we're going to be using that are very important. So, T subscript 1 is a variable used to identify the first term in a sequence, the first value in a sequence. T2 would be the second term in a sequence. So it's the second term. Well, then we have T of n, T sub n. And what that's saying is we know that it's a specific term, but the n tells us we're not sure exactly which term it is in the list. So this is the nth term in a sequence. We have a bunch of terms in order. We're not sure exactly which term it is. We call it the T of n. N will represent the number of terms within a sequence. And so that's why you know T of n, n is the nth term. We're not sure, it's whatever it is. The second term, when we have subscript 2, just like T of n, it's the second term. So this little n down here, this little number tells us which term we're dealing with. And D is what we call the common difference. The common difference, this is the value each term increases by. The value the terms increase or decrease by. So that becomes a really important value when we're talking arithmetic sequences. And the last thing to understand, well, is we have 2 different types of sequences here. Here, the first one, we have 8, 13, 18. Well, very quickly, from this, what do we have? Well, we have term 1 is 8. It's the first term. Term 2 is 13. That's your second term. Term 3 is 18. third term is 18. What else can we get from that list? Well, the ... tells us this is an infinite series, or sorry, infinite sequence. It goes forever. We don't know where it stops. The ... says it just keeps going. So it's infinite. The other piece we can get from this is our common difference. 8 becomes 13. 13 becomes 18. What are we doing each time? To get from term to term, we're having to add 5. So our common difference D value is positive 5. We can get all that from a list of numbers. Now, that's an infinite sequence versus the second situation here, where we still have T1 is 8, we still have T2 is 18, we still have the third term T3 is 18, but now we have 63 here. We have ... in the middle, which tells us there's a whole bunch of terms in there we don't see right now. We don't need to list all of them, but now we have this last term, which is a value of 63. Do we know which term number it is? We don't. So this would be called term T sub n. T of n is telling us that's a term, but we're not sure exactly which number term it is in our sequence. We still have a D value of 5 because 8 plus 5 is 13, 13 plus 5 is 18, and then we're going to add 5 and add 5 and add 5 and add 5 and get all these terms in here till we get to our T of n term, which is 63. Those variables will be very important through this whole chapter. Get used to seeing them. All right, here we go. Now let's start to do some thinking. Page 2, this example at the bottom, which of these are arithmetic sequences? And if they're an arithmetic sequence, what's the value of D? Well, when will they be an arithmetic sequence? If there is a D value. So in A, 2, 6, 12, 20, ... Is that an arithmetic sequence? Well, it's only a sequence if we have a common value going from term to term. 2 to 6 is plus 4, 6 to 12 is plus 6, 12 to 20 is plus 8. These are not the same. So this is not an arithmetic sequence. 9, 13, 17, 21 for B. Well, how do we go from 9 to 13? Well, that's plus 4. 13 to 17, that's plus 4. 17 to 21, that's plus 4. So this is an arithmetic sequence with a D value of positive 4. That's what we're looking at for an arithmetic sequence. C, 3 to 6 is plus 3. 6 to 12 is plus 6 right away. It's not an arithmetic sequence. 12 to 24 is plus 12. Well, even though some of you might see, oh, we're adding 3, and then we're adding double that, and then we're adding double that. Technically, if I were to continue this, I assume the next value would be plus double the 12, which is plus a 24, which would be 48. But who cares? It's not an arithmetic sequence because it's not a common D value. Now, D and E, we start to get to values or sequences that might not have a value that's quite as straightforward. Well, here's what's important. We can always calculate the D value by taking a term and subtracting the term previous to it. Whether it's taking term 2, negative 1.7, subtracting the previous term, which is negative 3.8. Negative 1.7, subtract negative 3.8. Don't forget change for integer work. We have a D value of 2.1. So from here to here is 2.1, but we have to make sure it works for all of them. So what's another way to get the D value? Take a term, which in this case I'll go to term 3, and subtract the previous term. So I can take term 3, 0.4, subtract the previous term, subtract negative 1.7, change. What do we get? We get a value of 2.1. So there you go. We have a constant D value. Let's do the last check. Well, the last check we could do here would be to take term 4 and subtract it from the previous term. 2.5, subtract the 0.4, gives us 2.1. So in all of these cases, we're adding 2.1 to go from term to term. So yes, it is an arithmetic sequence with a D value of 2.1. E, very quickly. Well, some of you might see it, some of you might not. Take a value, 5, subtract the previous value. 5 minus 11, negative 6. Let's double check that. What else could we work with here? Well, in this case, we could go negative 1, subtract the previous value. Negative 1, subtract 5, gives us negative 6. Last check, take the negative 7, subtract the previous value, and we get negative 6. So yes, this is an arithmetic sequence, and our common D value here is negative 6. Our difference is decreasing. Make sure your D value shows that. So that's what we're looking at with arithmetic sequences. Now, I'm not going to go through the big long explanation of why, and you can check your formula sheet, but this is the first formula within this chapter. What this formula is telling us is how we can calculate the value of one of the terms, whatever term we want, T of n, whatever we want. How do we do it? We take the first term and we add it to number of terms, subtract 1, get that value, and then multiply it by our common difference value. A straightforward formula, you just have to make sure you use it carefully. So, different people do it different ways. I like to always start questions by listing what I know. So, this question is saying, find the specific term asked for. Well, it's asking for term 22. What is term 22? Well, I'll be honest with you. Let's list what we know, and then I'll show you a shortcut, or not a shortcut, but a method some students will use that will not be accepted. What do we know in terms of our information? Well, we know we're looking for term 22. What's the first thing we need in our formula? The first term. Do we know what the first term is? Absolutely, it's 11. Do we know what n is? Do we know how many terms there are? Well, we do, because we know we want the 22nd term, so we're going to use 22 terms. Our formula also requires the common difference. Do we know the common difference? Well, we're going from 11 to 18, 18 to 25, and continuing it. Hopefully you can recognize just by looking at that, our common difference is positive 7. 11 plus 7 is 18, 18 plus 7 is 25, so our common difference is 7. Once we've listed what we know, now we can use the formula. Now there are students that on an exam will say, oh, 11, 18, 25, I don't know how to do algebra, I don't know how to use a formula, so I'm just going to add 7, because that's our common difference, and keep going until I get to the 22nd term. Well, you can do this process if you want. You will not get marks. All of the instructions, please understand, find a specific term asked for, you can add the word algebraically to every instruction that's given to you. Don't do it just by adding common differences and things. You need to be able to do it algebraically. So that means we want the 22nd term, knowing, and here's where we use the formula. First term is 11 plus, in brackets, the number of terms, 22 less 1, times the common difference, which is 7. Please make sure you follow order of operations. Brackets first, multiply second, and finish by adding. And by finishing this off, what we finish with, the 22nd term is 158. There's what we get for the 22nd term, using the formula for calculating any term for an arithmetic sequence. So I'm not going to do every example in the booklet every time. So kind of follow along. Sometimes I skip some. This page I'm going to do all of them very quickly though. So again, B, we want to find 10th term. We know T1 is -5. We know the number of terms is 10 because we want the 10th term. We know the D value, -5 to -1, -1 to 3. We're increasing by 4 every time, so our D value is 4. And we're trying to find T of 10. So our formula tells us the 10th term is T1, -5, plus N minus 1 times the D value. There's our formula. And as long as we can put the formula in, we should be able to solve it. -5 plus 10 minus 1 is 9. 9 times 4 is 36. So our 10th term, -5 plus 36, is 31. T1 is 31. Hopefully, that's fairly straightforward. From there, we go to C. Well, C becomes a little more complicated because it's fraction work. I got to be honest with you, fraction work should not be a problem, but it is for several of you. Well, to figure out the difference, first of all, having common denominator, 5/6, if I go to a common denominator of 12, it's going to be 10/12. How does 13/12 become 10/12? And then 10/12 becomes 7/12. Well, this is something, if you're in this course, you should be able to do without a lot of thinking. Fractions, 13 to 10, we've decreased by 3, and our denominator always stays the same. So 13/12 subtract 3/12 is 10/12. 10/12 subtract 3/12 takes us down to 7/12. There's our D value. T1 is 13/12. What else do we need? We need number of terms. We're looking for the 18th term, T18. So we know that that's 18. And now we can plug into our formula and solve because we're trying to find the 18th term. There's our unknown. So term 18. Term 1, 13/12 plus n minus 1, 18 minus 1 times D, which is -3/12. Now, -3/12. What's nicer than -3/12? Well, let's reduce that. Let's work with -1/4. That's way easier to work with than a -13/12. So let's make that correction. 18 minus 1 times a -1/4. Use a reduced fraction. Now a little bit of fraction work, because we all love fractions. 13/12 plus 18 minus 1. That's 17 times -1/4. 17 times negative 1/4. Numerators times numerators, denominators times denominators. Negative 17/4 is what we end up with. And now I have to add the fractions, but I need a common denominator. Yeah, you could use a calculator. However, what's better than a little bit of thinking? Common denominator of 12. 4 times 3 gets me 12. 17 times 3 is a negative 51. So our 18th term here, negative 13 plus negative 51, which leaves us with negative 19. That leaves us with negative 30. What do we get? 51. I got to double check this. 51 minus 13. 11 minus 5 minus 4 is 3. We get negative 38/12, which we should reduce to negative 19/6. There's our 18th term. Sequences series. Fractions are fair game. You're in 20-1. Get used to it. Just like with question D. D's a little bit more involved as well because we have polynomial expressions here. We want the 62nd term. We're looking for T62. Well, we know that our term 1 is 2x. We know that our number of terms is 62 because that's what we're looking for. Trying to find term 62, so 62 terms. What's our D value? 2x to get to 5x. 5x to get to 8x. What are we adding each time? We are adding 3 x's. 2x plus 3x is 5x. 5x plus 3x is 8x. So there we go. List what we know, and now we use it. Term 62. Term 1, 2x plus n minus 1, which is 62 terms minus 1, times our common difference, which is 3x. Polynomials, we can work with them, add, subtract, multiply, divide them, just like whole numbers. So the 62nd term will be 2x plus 62 minus 1 is 61 times 3x. Do the multiplying, which is 183x, plus the 2x. The 62nd term would be 185x. A nice, compact little formula that works really well as long as you understand what all the parts are and you remember all your algebra steps. All right, still lots of examples to go. Here, question 2, great question. Popular question for assessments because it's not about getting a final answer. It's about writing a simplified form for a T of n value. Basically, what it's asking you to do is substitute as much in and then simplify it. We're not going to get a final answer because we're looking for a simplified form, not just a final number. Still go through the same process. Well, now, because it's just a simplified form of T of n, we don't know exactly how many terms we want. But we do know term 1 is 6. We do know 6 to 13, 13 to 20. We do know that D is 7. That's our common difference. So I want to plug as much as I can into my formula. T of n is term 1, 6, plus n minus 1. Well, we don't know how many terms we have, so we leave it as n minus 1, and we multiply it by our common difference of 7. So I've plugged in as much as I can, but now I want to simplify it. So what that means, what can we do to simplify? Well, I can eliminate brackets because it's 2 terms times a monomial. I can distribute the 7. So I get T of n equals 6 plus 7n minus 7 because I've distributed the 7 to get rid of brackets. From here, oh, I can combine some terms. T of n equals 7n. 6 minus 7 is a negative 1. So what we have is our T of n general formula is this big thing. We have that whole thing, but for this particular situation, there's a nice little compact formula we could use. If I wanted to calculate the 123rd term, well, I could use the formula T of n, knowing what T1 is 6, knowing that n would then be 123, knowing that d is 7. I could calculate T of 123 using this. But I could also calculate the 123rd term for this situation simply by plugging 127 times 123 minus 1. This is a simpler version of this formula for this situation. That's what a simplified form does. So sometimes I'll ask you to do this. Please pause the video, try B, see what you get for a simplified formula. Start the video up again when you think you got it, and we'll take a look at how you did. So again, trying to simplify T of n. Well, we know that term 1 is 2. We know that our common difference, 2 to negative 3, negative 3 to negative 8, we're going down by 5 each time, so our common difference is negative 5. So let's now plug in and simplify. T of n will be term 1 plus n minus 1. We don't know how many terms, but we do know that d is negative 5. So what do we do from there? Let's get rid of the brackets to simplify. T of n equals 2. And then we have a negative 5 times n, which is a negative 5n. Negative 5 times negative 1 is a positive 5. And now let's fully simplify it. So T of n is negative 5n plus 7. An abbreviated formula instead of using the entire one for this situation. This will work really nice and quick. So simplified form is just coming up with a unique little formula for a particular situation. Page 4, continuing to example 3, lots to get through. Now, this is where you start to see that we have different things that can be asked for. You're not always going to be asked for the exact same value. Here, it's asking us to calculate the number of terms. What it's saying, hey, what's n? Here's a sequence, but we want to know this time what n is. A little bit different, but we're still using the same formula. So let's again list what we do know. Well, term 1 is 6. Perfect. 6 to 10, 10 to 14. Well, hopefully that's not too difficult, and you know that the difference, the common difference, is a positive 4. Every term's getting bigger by 4. What else do we know? Well, this time, we know what the last term is, but we don't know. There's term 1, there's term 2, there's term 3. We have a whole bunch of terms. We're not sure which term that is, but we can call T of n. We know 170 is the nth term. And the last thing, well, we don't know exactly what n is. So this time we know the T of n value, which we didn't previously, and we can use that to solve n. So if we go to our formula, T of n equals T1 plus n minus 1d, well, 170 equals, because now we know the T of n, term 1 is 6, plus n we don't know, minus 1, and we multiply that by our d value, which is 4. So instead of just solving for T of n, we're going to solve for n. A little bit of algebra. What can we do for algebra? Well, let's distribute to get rid of brackets. 6 plus 4n minus 4. Combine your like terms. 170 equals 4n plus 2. And now we get n by itself. Subtract 2. 168 equals 4n. Divide by 4. And we end up with 42 equals n. So what does that tell us? That tells us that 170 is term 42. The 42nd term is 170. Using the formula for the term to calculate for something other than the term. Pause the video, give B a try, see what you can come up with on your own, and then we'll talk. All right, here we go. Again, I like listing. Term 1, 8. Common difference. 8 to 1 is down by 7. 7 less is negative 6. 7 less is negative 13. Negative 7 is the common difference. There we go. What else do we know? Well, we know the last term, t of n, is negative 146. Watch your sign. And we know we're trying to figure out how many terms there are. So from there, here we go. Let's plug into our equation. Again, we know t of n in this case, a little bit different. Negative 146 equals first term, which is 8, plus brackets n minus 1. We don't know n, but we do know the common difference is a negative 7. And now we can solve for n. Algebra tells us, get rid of brackets. Distribute the negative 7. Watch your signs here, folks. Negative 7 times n is a negative 7n. Negative 7 times negative 1 is a positive 7. Combine your like terms. Negative 146 equals negative 7n plus a 15. At that point, now all we have to do is isolate the n. Subtract 15 from both sides, which leaves us with a negative 161 equal to negative 7n. And from there, divide by negative 7, and n equals 23. So again, what does this tell us? It's telling us the 23rd term is that last term in our sequence, negative 146. So you're not always finding the nth term. Sometimes you're using that formula to find other stuff. All right. Example, still page 4, but now fractional form. Oh, because we love fractions. Got to be able to work with them. Pause the video, give it a try, see what you come up with, and then come back. All right, here we go. What do we know? Well, we know the last term is 16/3. Now, I have some students in the past will say, well, 16/3, let's just make it a decimal and work with the decimal. Well, if I change 16/3 into a decimal, we end up with 5 decimal 3 repeating. Well, 5 decimal 3 repeating, I can't use a rounded value. Well, let's just use 5 decimal 3. Go ahead, but you're going to be wrong. We need to use exact values. So in this case, we can't get a terminating decimal. If the decimal terminates, well, you can get away with it. But you have to understand that working with fractions is important because it gives us exact values instead of rounded values. So we need to use 16/3 as t sub n. We know the first term is 1/3, which is decimal 3 repeating. I can't use decimal 3 because that's not what 1/3 is. 1/3 is decimal 3. So we have to work with 1/3. Now the d value, a little tricky. I'm going to make everything sixths. This is really a 2/6 with the 5/6, 8/6, Well, 2 6 to 5 6 is plus 3 sixths. 5 6 to 8 sixths plus 3 sixths. So our D value is positive 3 sixths, which is just 1/2. So our D value is 1/2. Is there anything else we know? I don't think so. We know we're trying to figure out how many terms there are. So here we go. T of n, 16/3, is equal to term 1, 1/3, plus n minus 1 times d, which is 1/2. Multiply. Get rid of brackets. 16/3 equals 1/3 plus 1/2 n minus 1/2. Well, combine your like terms. Oh, fractions. I love fractions. 1/3 subtract 1/2. That's the calculation. A 1/3 and a negative 1/2. Well, common denominator is 6. I don't need a calculator. Let's do this in our heads and get better at it. That leaves us with 16/3. 1/3 subtract 1/2 gives us a value of negative 1/6 with the half n. 1/2 n and a negative 1/6. From there, add 1/6 to both sides. 16/3 plus 1/6. Yeah, you can do this quickly without a calculator. Common denominator of 6. 32/6 plus 1/6 is 33/6, equal to 1/2 n. 33/6. Now we divide by a half to finish it off. We're going to divide by a half. Watch this. I can do this without a calculator too. 33/6 divided by a half. We don't divide fractions. What do? We multiply by the reciprocal, 2/1. That leaves us with 33 times 2, which is 66. 6 times 1 is a 6. We're left with 66/6, which is really just 66 divided by 6, 11. Look at that. All that fraction work without a calculator because you practice it. So what do we know? We know 11 terms. 11 terms. Term 11, when we take a look, which was our term 11? Our term 11 was the 16/3. So we know there's 11 terms in this one. Oh, we keep plugging away different scenarios of asking similar kinds of questions. All right, still on page 4. Example number 4, find the missing terms. Well, this is an interesting one because of the way it's drawn. This first one, we know what T1 is. It's 29. We know 1, 2, 3, 4, 5. It's not ... These 3 blanks tell us there's 3 numbers there. So we have a total of 5 terms. The 5th term is -6. And we want to figure out what are these terms in the middle. Well, what helps us to go from term to term? Well, we need to figure out what the D value is. So we know term 1 is 29. We know the 5th term is -6. We know there are 5 terms. We don't know what D is. So that's what we need to figure out. Because if I can figure out the common difference, I'm just going to add or subtract each time. But looking at this without even doing anything, what do we know about D? Well, I hope you understand that D has to be negative because we're going from 29 to a -6. We're getting smaller. So our D should end up being a negative. So we plug into our formula. Our formula tells us that T of n, which is in this case T of 5, the 5th term, is -6. And that's going to equal term 1, 29, plus n minus 1. We know there's 5 terms, times the common difference we don't know. Here we go. Same formula, but now finding a different unknown because our T of n is known. Well, what am I going to do? Well, 5 minus 1 is 4. So I have negative 6 equals 29 plus 4d. And there you go. I just want to get d by itself. Subtract 29, get negative 35. Oh, I made a mistake here. Just a sec. Oh, this is bad. I apologize, folks. My slide and your booklet is a little different. There's an extra line in there. I apologize. So we're actually looking at term 6. I am so sorry about that. Sometimes these little errors happen. So the 6th term is negative 6 because the booklet has 4 blanks in there. So we're dealing with t of 6, which means the number of terms is 6, which means we end up with 5d. Sorry about that, but quick little fix. Mistakes happen. We correct them. So we still, though, doesn't change. Negative 29 on each side, negative 35 leaves us with a 5d, but that now leaves it a nice, simple division. Negative 35 divided by 5, our common difference is negative 7. So there we go. The common difference, negative 7. So what are the missing terms? If we're doing negative 7 every time, negative 29, and again, I have to fill in 4 of them. So negative 29 less 7 gives us 22. Less 7 gives us 15. Less 7 gives us 8. Less 7 gives us 1. Less 7 gives us negative 6. It worked out. Puts a smile on my face. Now with B here, B has some uniqueness to it because we don't know term 1. We know there's 1, 2, 3, 4, 5. Double check my example. Is that what we have? Yes, it is. So this is term 5. But this is tough because I don't know term 1 and I don't know the d value. I can't find 2 unknowns in a question. Here's a trick in this case. We're going to be going up or down with a d value consistently, whether this is the first term or term 2. So let's cheat in this case right now, and let's actually call 19 term 1. And let's call number 7 term 4. Let's just pretend that this term doesn't exist right now. Our d value is going to be consistent. So we can still calculate d, except instead of using 19 as term 2, we'll use it as term 1. Instead of using 7 as term 5, we'll use it as term 4 and calculate d. So term 1 is 19. We know that term 4 is 7. We know the number of terms is 4. And we're trying to calculate what is d, the common difference. So we can cheat a bit because we know that this is going to be a common difference no matter where we start. So t of n, or in this case term 4, is 7, which equals term 1 plus n minus 1, 4 minus 1, times our common difference, which we don't know. 7 equals 19 plus 4 minus 1 is 3. 3 times d is a 3d. And now we solve for d. Negative 12 is equal to 3d. Divide both sides by 3, and d is negative 4. So now I can go back to this original question, and we now know the common difference is negative 4. So 19 minus 4 is 15. Minus 4 is 11. Minus 4, there's our 7. It worked out. But what do I subtract to get subtract by 4 to get 19? Well, it's the same as adding 4 to go that way. There's a 23. There's our values because we had to calculate the common difference. all kinds of different ways we calculate the same thing. And again, find the missing terms. I didn't say this earlier, algebraically. Yes, guessing and checking, absolutely it could be done. But that's not going to get you marks. Otherwise, we're going to start using values that are so big and everything's going to be fractions, so you have to show algebra. We give you some nice values to work with. Get the algebra steps down. Couple more questions, a little bit tricky. Let's think about these. I know it's been a long video, we're getting close, but got to think about other situations here now. So we are trying to find, in the end, term 1. And we know, what do we know? We know that in our list, the 16th term, our t of n, term 16 is a total of negative 18. Negative 18 is on the end of our list. We know our d value is 4. We know one piece more of information from that equation. What else do we know? We know that n is, what's n? Oh, n is 16, because I know that the 16th term is negative 18. So that's what n's telling me. So I can now substitute in using my formula. T of n, which is t16, is negative 18. That's term 1, which we don't know, plus n minus 1 is 16 minus 1 times d, which we do know is 4. Well, what could we do in order to isolate t1? Well, we can. 16 minus 1, that's 15. 15 times 4 gives us 60. T1 plus 60 is equal to negative 18. How do I get T1 by itself? Just subtract 60. Negative 78 equals T1. Another way of using this formula when T of n is given to calculate another unknown. It's all about understanding how to isolate a variable. Number 6, love this question. This is an interesting question, requires some thought. So we want to figure out what x is. So in each term, so we have 3 terms here. I could say that this is 2x plus 3 is term 1. 5x minus 1 is term 2. And 7x plus 4 is term 3. Well, I got to figure out not only what the 3 terms are, but what the x is that can create those 3 terms that creates the arithmetic sequence. Oh, this question, it requires a little bit of thought. Take a second and tell me, think about it. What is so important in the arithmetic sequence? Well, the arithmetic sequence always has a d value. But think back a while, and what did we talk about? How do we calculate d? Well, d is a term subtracting the term before it. So I know that if I take my second term, 5x minus 1, and I subtract the term before it, term 1, I'm going to get a d value. But I have to be careful, because my 5x minus 1, I want to subtract all of this term. Anytime I subtract a polynomial, I need to put it in brackets. So this is saying term 2 subtract term 1, well, that's going to give me a d value. But why is this d value so important? Because there's another way to calculate the d value. The d value can also be calculated by taking the third term and subtracting the second term. So here's term 3, and if I take the third term and I subtract the second term, it's going to give me that d value. So d is going to be 2 minus 1 in terms of terms, but D is also going to be term 3 minus term 2. But what's important? D's the same. So that all of a sudden just becomes one big equal sign. This calculation is going to be the exact same as that calculation because they're both values of D. Yeah. Beauty question. Love it. But now you got to solve for X. Lots of work. Get rid of brackets. Distribute the negative. 5x minus 1 minus 2x minus 3. Distribute the negative over here. 7x plus 4 minus 5x plus 1. Because it's a negative times a negative. Now I can combine like terms on each side of my equation. 5x and negative 2x is a 3x. Negative 1 and negative 3 is a negative 4. 7x and negative 5x is 2x. And positive 4 and a positive 1 is positive 5. What do I do now? Get rid of the 2x from this side. Do the same to that side. Take the 4 away from the x by doing the same thing to both sides. And we're saying that x has a value of 9. Because of the idea that this is a D calculation, this is a D calculation, so they should be equal and we can solve. Let's do a quick check now. If I put 9 in for x, 2 times 9 is 18. 18 plus 3 is 21. I think x is 9. 45, 5 times 9 minus 1 is a 44. And then finally, what else does that leave me with? 7 times 9 is 63. 63 plus 4 is 67. 21, 44, 67, D value of 23. So x equal to 9 is a value for x that allows us to create an arithmetic sequence. Beauty question. Love it. All right. Example 7. All right. With example 7, 2 ways to approach it. I will show both. So if you want to know both, here we go. The first way, well, it's kind of the cheater way. We know there's 7 terms. We already kind of saw a question like this. We have term 1, term 2. We know term 3 is 27. But we also have 3, 4, 5, 6, and term 7 it says is negative 5. So we have 1, 2, 3, term 3 is 27, 4, 5, 6, 7, term 7 is negative 5. One way to do this is to look at it and cheat a little bit by having the blanks. How do I come up with T1 and D? Well, as much as we need T1 over here, we can cheat by using 27 as T1 to start, TM2, 3, 4, and we're going to use negative 5 as term 5. That's just to allow us to come up with a D value. Because whether this is term 1 or this is term 1, it's going to be the same D value. So we're cheating a bit. Our Tn value, now we go to plug into our formula, is negative 5. That's our T of n. Term 1 is 27. D, we don't know. But we do know that our n, because we're dealing with 5 terms right now, is 5. So here we go. Negative 5 is our T of n, equals 27 plus n 5 minus 1 times our D value we don't know. So we can solve for D. Done a fair bit of this algebra now. 5 minus 1 is 4. Minus 27. And D is negative 8. So as much as D is negative 8, I still need term 1 but term 1 isn't 27. This is actually our term 1. So if I'm going down by -8 each time, I need to actually add 8 to get 35, add 8 to get 43. Term 1 is 43. So that's one way to do it, kind of that little bit of cheater method. All right? But here is another way to approach it, building on information from the 10th C class. Algebra. Well, what we can do here is a system of equations. We can create a simplified equation, simplified form for each of these. If we know T3 is 27, then building on this idea of Tn equals T1 plus n minus 1 times d. Well, we know that T of n is 27 equal term 1 we don't know plus n. We do know that in this case we have 3 terms, so it's 3 minus 1 times d. Well, 27 equals 3 minus 1 is 2, T1 plus 2D. There's a simplified equation. Well, let's now do the same thing with our T7 equal to 5. So -5 is our T of n. Term 1 we don't know. N minus 1, we know there's 7 terms, and we don't know the D value. So if I simplify this one, 7 minus 1 is 6. Well, what do you see here? We have now 2 equations with 2 unknowns. This goes back to systems in Math 10C. If I have 27 equals T1 plus 2D, -5 equals T1 plus 6D, I can solve the system using the substitution or elimination processes. Yeah, going back a little bit. How do we do that? Well, we have to multiply one of the equations to create an additive inverse. I'm going to multiply the second equation by -1. Multiplying by -1, key is going to take my T1 and make it a negative T1, which will allow T1 and then my negative T1 to cancel. So my first equation stays the same. And my second equation becomes, sorry, not -5, because I have to multiply all parts of it by -1. It now becomes -1 times -5 is 5. -1 times T1 is a negative T1. And -1 times 6D is a negative 6D. Combine these, those cancel, leaves me with 32 equal to -4D. Divide both sides by -4. D is -8. And that's what we said earlier. D is -8. So if my third term is 27, I have to add 8 to get 35. Add 8 to get a T1 of 43. Systems of equations. Because there's 2 unknowns, we can always set up a systems. A little bit different. All right. Last question. Not quite last question. I know we're into this for a while. Videos are not normally this long. It's just lots of information in one. So here we go. What do we have here? You can read the entire question, but it comes down to the fact that a diamond mine is producing diamonds. It produces 3.8 million carats in 2003, which we can say is first year. The life expectancy, so this is our T1. The life expectancy of a mine is 20 years. So we know that 20 is our N value. And we know that in year 20, 113.2 million carats are taken out. So that's the last year, which actually we could call T of N, but we do know specifically in this case, it's 20 years. So this diamond mine produces 3.8 million carats. And then because it's telling us it creates an arithmetic sequence, it creates so many more million the next year. And then the third year, it creates that same amount more. And then the next year, it creates that same amount more. Until in the 20th year, it comes up with 113.2. So that's what's happening. Produces a little, produces more, a little bit more, produces a little bit more, produces a little bit more, until 113.2 million carats in its last year. Find the common difference, which is our D value. There's our information. 113.2 is our T of N. Term 1 is 3.8. 20 minus 1 times the D, which is what we're trying to find. 20 minus 1 is 19, so we get 113.2 equals 3.8 plus 19D. Subtract 3.8, and we end up with 113.2, subtract 3.8. Oh, I have to do that math. I can't do that one in my head. It hurts. So really quick, 12 minus 8 is 4. 12 minus 3 is 9. 109. No, that's not right. Yes, it is. Perfect. 109.4 million carats equal to 19D. Divide both sides by 19. And D works out to be 5.757, blah, blah, blah. So what does that tell us? 5.75. Well, it's not an exact value. So what are we going to say? About 5.8 million carats. So what does the common difference represent? That means that each year the mines gets 5.8 million carats more than the year before. So that is what the common difference tells us. Got 3.8. They got 5.8 million carats more the next year, which would take you to 9.6. Then they got 5.8 million more carats the next year than the 9.6. So that's what your D value tells you. Last one, like this one, and then you can practice. I know it's a long video. Most of them won't be this long as the units go on. So it is what it is. This question says, determine the number of multiples of 7 between 14 and 210. So that means 14. What's the next multiple? We want multiples of 7 between those. Well, 14, the next multiple of 7 is 21. 28 is the next multiple of 7 because these are what you multiply to get 7. And then we go to 35 and so on until we get to 210. That's what the question's saying. Multiples of 7, 14, 21's a multiple of 7, 28's a multiple of 7, 35's a multiple of 7, 42, 49, up to 210. So term 1 is 14, and we don't know what T of N is. So what do we know? T1 is 14. We don't know the number of terms. We know the last term is 210. What else do we know? T1, N, Tn. Is there anything else that we know here? I don't think so. So what do? Let's figure out what D is. Formula T of n, 210, is term 1, 14, plus n minus 1. N minus 1. But do we know what D is? Sure we do. How do we go from term to term? Because it's multiples of 7, we're looking at a D value of 7. So we have a D value of 7. So now we can solve for n by distributing the 7. So in this case, because it's multiples of 7, when I list it, I see that our D value is 7. So at this point, solve for n. Combine those two terms, which gives us 7 plus 7n. Subtract 7. And divide by 7. And we end up with 29. So including the 14 and 210, there are 29 multiples of 7. So that's what we're looking at. Multiples of something, another way to talk about the fact that we end up with an arithmetic sequence. Now I love question B because you got to think and some of you don't think. Same question. How many multiples of 7 are there between negative 51 and 348? But what we have to be careful of is we want multiples of 7 again. But term 1, a lot of students all of a sudden say, oh, negative 51. But the problem is negative 51 isn't a multiple of 7. The first thing between these two that is a multiple of 7 is negative 49. So our first term isn't negative 51. The first multiple of 7 is negative 49, and then negative 42, and then negative 35, and so on until we get to 348 isn't our last multiple of 7. 343 is the last multiple of 7. So you have to be careful. Negative 51 and 348, that's not T1 and Tn like it was in the first one. T1 is negative 49, and T of n is 343 because those are the multiples of 7. So here we go. 343 equals T1, negative 49, plus n minus 1 times D, which again, because we're looking at multiples of 7, is positive 7. 343 equals negative 49 plus 7n minus 7. And when you solve for n, you should end up with 57 multiples of 7 between negative 51 and 348. There will be 57 numbers between those two that are multiples of 7. Oh, lots of examples there. This unit will be the longest videos. Lots of things to do, lots of ways to look at different questions that are very similar. Textbook, that's your assignment. Pages 16 to 19. Those numbers, that's what you need to be working on. That's what's expected to be done. Have fun with it. I know it took some time, but get her done.